Finally, back to another video, and now we're going to be looking at sigmatropic reactions. We've gone through a lot of reactions relating to cyclic additions, like for example electrocyclic reactions, and now we're kind of done with that and we are focusing on something quite interesting which I really love too, is sigmatropic reactions, or people can actually call it a sigmatropic rearrangement. Now this rearrangement focuses on a Clasien rearrangement that was first discovered by him, of course, and he discovered this particular pathway where if you have this particular compound, if you just subject it to heat without any solvent at all, what we do get is a particular compound, which is what we got over here. Now this compound here started off with this aryl allyl ether, which goes under the presence of heat to form an ortho, which is with respect to this and that, allyl phenol. Now, how is this actually performed without the presence of a solvent? Now, there are actually two steps to actually take note of. First of all, it's kind of a numbering system that we need to be aware of. The numbering system focuses on one particular segment here, which we call the 1, 2, 3, 3 being the last part of the double bond, and while on the other side we start off with an heteroatom, which in this case is oxygen, going 1, 2, 3, where 3 is the last end of our double bond on the other side over here. Now take also note that this numbering system enables we to actually name it a 3 sigmatropic rearrangement. And why is it sigma? The sigma is actually due to the one of the arrows starting off with a sigma bond. So by so doing, if we start our mechanism starts off with this particular step here, where we have our benzene attached to this, and then we change the rotation in such a way that we can start our cyclo addition process, where we actually number it first 1, 2, 3, just to keep track. 1, 2, 3. Now the bonding of our sigma here start off here, and here we have to break a sigma bond, which is actually a weak bond here. This forms a double bond here, 1 to 1, so that is where you focus on, and then this forms a sigma bond here, and then this forms a pi bond here. So what we get as a result of this 3 by 3 sigmatropic rearrangement is an intermediate, which is an non-ionic intermediate. So there is no ion at all in our intermediate. What we have is this particular species. I'll still repeat myself again, non-ionic. So there is no ion at all present in our intermediate. Take note that there is a hydrogen here, which is here as well, but since this is not aromatic in terms of this ring, for we to actually make this to be stable, there is a case where we need to be able to add our second step, which is to actually add an acid. So once we add an acid in here, what we have is a process where water will actually come in and actually pick up this proton, and then what happens next is that this proton here bonds with the oxygen to form an acid, and then this bond actually forms a double bond here, and this actually picks up a proton in here to form an alcohol in there. And what we are able to do is to regenerate our aromatic ring, which is the 6-membered ring over there. and we have phenol there that is also to allele over there. So this leads to the restoration of our aromaticity due to it is an energetic favorability in terms of going from this particular part to this particular path over here. So that's about it for this particular video. I will give you guys more examples, or we'll go through more examples just to clarify some very specific terms that we need to take note of, looking at how this is a non-ionic intermediate, and looking at how we are able to restore our aromaticity, and also how we are able to also number our system just to identify this particular type of reaction. Thanks for following me through this, truly appreciate it. Be smart and subscribe. Bye.